Hi, everyone. I wanted to make a few comments about some notational um, things involving number systems and sets. So just because it comes up all the time, and I thought I might as well do it as a separate short video. So there's lots of, for different classifications of numbers, there's lots of sort of standard mathematical symbols, like, for example, this R, sort of like the double-backed R, some people call it blackboard bold, is the real numbers. That's just the standard number line, like everything you could think of. And then you have things like Q, or the rational numbers, everything that's a fraction. You have, and then this is kind of weird, but the integers are actually used with Z. It's for it's the German word for integers, Zahlen. And so, for example, we could say things like, the square root of 2 is a real number. Let me try to write that better. Square root of 2 is a real number. And so this little sign here is sort of like belongs to the set. It's like the way people say it is an element of. So the real numbers is a set. It's a collection of sort of every number on the number line. And so root 2 belongs to the real numbers, right? And something like 5/3 belongs to the rationals. Something like -7 belongs to the integers. But also -7 belongs to the rationals also, right? It counts, integers are rational and are real. And so in fact, we say something like this where the integers is a subset of the rationals, and that's a subset of the real numbers. So this is another notation which kind of looks like the little element sign, but it's a little bit different. It's a little bit annoying that they look so similar, but this is the subset symbol. So, every integer is a rational number, every rational number is a real number, etc. So that's some basic set notation that I might start using. And then if we wanted to talk about 3D space, we have or n-dimensional space. So Rn is the set of, it's the set of all, n tuples of real numbers. So, R2 is like the standard XY plane. 2 is the XY plane. R3 is XYZ space. And it's so what I want to say is that there's kind of a more general notation for sets. So let me talk about set notation, and I'll come back to this Rn thing in a second. So set notation. Like, say I wanted to talk about just all the even integers. Even integers. Well, you could give that a name. Let's just call it like E. So E is the set of even integers. Here's a way to write it. You could write it as something like the following. 2n, where n is an element of Z. And so let me just write this in words. So so these things are set brackets, right? And so the way I would write this in words is this is everything of the form, everything of the form 2n, where that vertical bar is sort of like, people read that as where n is an integer. We need to specify sort of like what the numbers come from. right? If I said 2n where everything's a real number, then that gets kind of weird. That's a lot bigger than just even integers, because like now 1 would be in that set because 2 times a half. So it's nice to specify that we're actually pulling only things from the integers. Okay, and so this is a very standard thing where you sort of put something, there's this vertical bar here, you put something before it, which is sort of the form of what you're looking at, and you say something after to say, like, you know, just to make sure like where everything comes from. There are other ways to use set notation, but that's a pretty basic one. So you could also think, so just as another example, you could think of something like Rn as the set of all n tuples x1, x2 through xn, where each xi, and sometimes people are, I could say x1, x2, x3, etc., but I'll just say xi is a real number for all I. Right? And that's sort of the standard way we write stuff. If I wanted, say, all the real, if I wanted to say, like, maybe I want the XY plane in three-dimensional space, right? So you could also do something like that. You could say the XY plane in 3D is the set. You could just say something like x1, x2, 0. It's really the x1, x2 plane, I guess, not the xy plane, but you get my drift, where x1 and x2 are both real numbers. You could do something where you'd say it's like x1, x2, x3, where x3 equals 0. You could also write something like that if I wanted to, but you know, you might as well just write where, so x1, x2, x3 are all real numbers and x3 is 0. But it's easier just to write the first one, so I tend to do that. Okay, so you'll see a lot of things like this in books where you have sets, and I just want to get you guys used to that notation. So I'll stop that video there.